Welcome to my YouTube channel ErudiSpace. I am Dr. D Mohanty, and today's lecture will discuss about the specific heat, sensible heat and latent heat. These are all fundamental things and are required for all science and engineering students. Although these are fundamental things, most of the students do have a problem in understanding the concept. So, in today's lecture, first I'll tell you what is specific heat with a special emphasis on specific heat of gases, why we use two specific heats when it comes to gases, whereas there is only one specific heat when it comes to solids and liquids. Then we'll discuss about the sensible heat and latent heat. Specific heat is the term that we have been studying from our upper primary level. And what is specific heat? Specific heat of a substance is the amount of heat required to raise the temperature of unit mass of substance through 1 degree Celsius. If Q is the amount of heat transfer, that is the product of mass of the substance multiplied by specific heat multiplied by delta T, where delta T represents the difference in temperature. So from this we get specific heat equal to Q divided by N del T. That's what I told you. The specific heat is the amount of heat required to raise the temperature of unit mass of substance through 1 degree Celsius. Now, when it comes to solids and liquids, we do have only one specific heat represented by C. But we do use two specific heats when it comes to gases, and these are known as specific heat at constant volume and specific heat at constant pressure, CV and CP. Why we require two specific heats? For that, we must understand the fundamental difference existing between solids, liquids and gases. Suppose this is a solid object. You have some liquid in a container, and then you have some gases in a closed vessel. Now, what is the fundamental difference between solids, liquids and gases? Here the molecules remain in their particular position. They may vibrate, but they cannot interchange their position when it comes to solids. In liquid, the molecules do interchange their position, but they cannot move apart. Then you have gases. In gases, they can interchange their position, they can move apart. If the boundary is not fixed, it's movable, they can occupy any volume. So there is a fundamental difference existing between the molecules in solid state, liquid state and gaseous state. But what is common between solids and liquids? That they do have a fixed volume. Solids have a fixed shape and fixed volume. Liquids have fixed volume, although they do not have a fixed shape. They take the shape of any container to which they are put into. Gases do not have a fixed shape or fixed volume. So now we'll apply the first law of thermodynamics for a closed system undergoing a change of state, and from that we'll analyze why we require a single specific heat when it comes to your solids and liquids, and why we require two specific heats when it comes to gases. So all of us know that as for the first law of thermodynamics, for a closed system undergoing a change of state, the amount of heat added is equal to the change in internal energy represented by delta U plus external work done. And you should remember that when work is done by the system, it undergoes expansion, and when work is done upon the system, it undergoes compression. So when it comes to your solids and liquids, it doesn't undergo any expansion, or the expansion is negligibly small. So you can say with reasonable accuracy that for solids and liquids, the amount of heat added is equal to the change in internal energy, which brings about a rise in temperature. So you have only you do have a single specific heat. But when it comes to your gases, it depends upon whether you allow the gases to expand or not. Let us consider another container with some amount of gases, and you do have a cover here which can move up and down. That means you are allowing the gases to undergo expansion. So now we have two specific cases. Here there is no change in volume. You are not allowing gas to expand. In that case, Q will be equal to del U, as has been when it comes to solids. But when, you can mention here, when volume is fixed, but when you allow the volume to vary, keeping pressure fixed, then Q will be del U plus W. So when pressure is fixed, this actually corresponds to CV, and this corresponds to CP. Now, what is the fundamental difference between CV and CP? In this case, whatever is the heat added is stored as increase in internal energy, which brings about a rise in temperature. Whereas in this case, part of the heat energy is used in expanding, and the remaining part is stored as increase in internal energy, which brings about a rise in temperature. And for that reason, CP is always greater than CV, because in this case almost the entire heat energy is stored as increase in internal energy, which brings about a rise in temperature. Whereas in this case, a part of the heat energy is undergoing expansion, and the remaining part is stored as increase in internal energy. So for that reason, we do have two specific heats when it comes to gases, whereas you do have a single specific heat when it comes to your solids and liquids. So after discussing the specific heat, now our focus will be on sensible heat and latent heat. First I will tell you why we call it sensible heat and why we call it latent heat. Sensible heat transfer is the heat transfer associated with rise in temperature. That is something that you can sense. The rise in temperature is something that you can sense. But what is latent heat transfer? Latent heat transfer is the heat transfer which is associated with only change of phase. No rise in temperature is observed when it comes to the latent heat transfer. Now, I will show a typical example to make you understand that why we have sensible heat transfer and why we do have latent heat transfer, and how the phase change is related to the latent heat transfer. So this is the temperature, this is the heat added. First, we have a solid phase followed by a phase in transition, which is a combination of solid and liquid, and then this one is liquid, then again a transitional phase which is liquid plus vapor, and the last one is your vapor. This one is solid or S, this one is liquid or L, this is your gases represented by Z. Now, this is an intermediate phase, solid plus liquid, and this is again an intermediate phase, liquid plus gas. Now, we do have two latent heats. This is called latent heat of fusion. This is called latent heat of evaporation. So with this diagram, I will explain what is actually sensible heat addition and what is latent heat addition. First, this is your sensible heat addition, where there is increase in temperature of the solid substance. This one is your latent heat addition, followed by again sensible heat addition, followed by latent heat addition, followed by again sensible heat addition. So the entire diagram is split into 6 parts with alternative, sensible and latent heat addition processes. We know that in sensible heat addition, the heat addition is associated with rise in temperature. That is something you can sense. You can measure the difference in temperature when heat addition is taking place. Then this is actually your latent heat addition. So here what happens? Heat is added, but this heat addition is not associated with any rise in temperature. This heat energy is actually utilized in converting the solid state into liquid state. So why this heat energy is required? Because we know that in solids the position of the molecules are quite rigid. They even cannot interchange their position. So this heat energy is actually utilized in overcoming the force of attraction existing between the molecules in case of solid. This is what we call your latent heat of fusion. After that, once the entire solid is converted into liquid, on further heat addition there will be a rise in temperature, and this represents again a sensible heat addition process. Once this condition is attained, then again it will absorb heat which is not associated with any increase in temperature. So here what is happening? Here again the heat energy is being utilized in overcoming the force of attraction existing between the liquid molecules. We know that in liquids, the molecules do interchange their position, but they cannot move apart. So, for that some amount of heat energy is to be supplied. So this is nothing but your latent heat of evaporation, and once the entire liquid is converted into gas on further heat addition, there will be a rise in temperature. Latent heat addition may be from solid, it may be at liquid. When it is done in case of solid, it is converted into liquid, and when it is done in case of liquid, it is converted into gas. Now, both the latent heat addition processes are endothermic processes. They do absorb heat energy, and the reverse processes are exothermic processes. That means the gases may be converted into liquid, thereby liberating or releasing the latent heat. Similarly, the liquids may be converted into solid, again liberating the heat. So now I sincerely believe that your concept about the specific heats, sensible heat and latent heat would be crystal clear. Thank you very much for watching this video. If you have any doubt about all these three terms, you may put questions so that I will try to answer your questions. Thank you very much. Hope to see you soon for another lecture.